This is worksheet 3 of the thermochemistry packet. This is a 2-page worksheet, and so you should have already read the first page talking about the basic idea of enthalpy and exothermic and endothermic reactions. But what I'm going to talk about in the video is how to do the calculations related to enthalpy. So if you read up here at the top of your screen, enthalpy changes are really similar to the stoichiometry and moles problems that we learned to do earlier in the trimester. So if you think back to what you know about those kinds of problems, it will help you to do these problems more easily. The central idea here on this worksheet and this calculation is that the amount of energy either absorbed or released during a reaction really depends on the number of moles of reactants involved. So the more reactants you start with, the more energy is going to be absorbed or released because you're going to have a bigger reaction occurring. And vice versa, the fewer moles of reactants you start with, the less energy will be absorbed or released because you'll have a smaller reaction occurring. So if we look at an example, in the following equation, they're showing 1 mole of carbon reacting with 1 mole of water, because remember the coefficients in front tell us the number of moles, so there's no coefficients here, we assume that they're 1. And it's saying that 113 kilojoules of heat are absorbed. The positive sign means absorbed. If it was a negative sign, then it would mean that the heat was released. Okay, so if you think about this, right, you can probably figure out the answer to this question here. See if you can. How much heat would be absorbed if 2 moles of carbon were combining with 2 moles of water? In other words, if I made this a 2 here and this a 2 here, how would that affect this number? Right? It really should just be twice as much. So 113 times 2, a little quick calculation, is 226 kilojoules. All right? Twice the amount is going to be absorbed because you're starting with twice as many reactants. So effectively your reaction is twice as big. All right, so let's use that to do a calculation. Here is our first example problem, and this is what your homework is going to be like. The example problem asks how much heat will be released if 1 gram of hydrogen peroxide, H2O2, decomposes. So we have an equation for that reaction here, and it's showing that if you start with 2 moles of hydrogen peroxide, it's going to break down into 2 moles of water, 2 moles of oxygen, and it is going to release 190 kilojoules of heat. So we're going to set up a stoichiometry problem here, basically. What we want to find is the amount of heat, right? Heat is measured in a unit called kilojoules, lowercase k, uppercase j. So we want to find the number of kilojoules that are going to be released if we start with 1 gram of H2O2, because that's what the problem told us we had, right? And so our first goal is to get rid of these units of grams. Well, you know, when you think grams, you should think molar mass, right? So if we want to get rid of grams of hydrogen peroxide as our units, we're going to need to calculate the molar mass of hydrogen peroxide first. So I did that over here already, okay? You already know how to do this calculation. 2 hydrogens, well, each hydrogen weighs 1.01, so 2 hydrogens is 2.02. 2 oxygens, well, each oxygen weighs 16. We can look this up on the periodic table, which means 2 oxygens would weigh 32. And if we add this together, we get the molar mass of hydrogen peroxide to be 34.02 grams per mole. So, just like you've done many times before, you're going to plug that into a stoichiometry problem here, a little factor label problem. The 32.02 grams is going to go on the bottom so that we can cancel out units of grams on top and bottom. And that's equal to 1 mole of hydrogen peroxide, which goes on the top. Now, the second step is the one that's going to be a little bit different, because we haven't used kilojoules or heat in a stoichiometry problem before. But this balanced equation tells us that if we start off with 2 moles of hydrogen peroxide, that's the coefficient in front of the H2O2, we will release 190 kilojoules, so negative 190 kilojoules of heat. So on the bottom of our factor label, we put the 2 moles. We got that from the coefficient here, right? Which means we can cancel out the moles unit. And on the top, we're going to put the negative 190 kilojoules, which we also got from the balanced equation. So now we just have to go through and do our calculation. We'll do 1 times negative 190, and then divide that by 34.02. So we get a negative number here, which I then just rounded to negative 2.8 kilojoules. And remember, you have to include the sign, because here the minus sign is telling you that heat is being released, right? That this is an exothermic reaction rather than endothermic. So whether it's positive or negative matters. All right. So we'll go ahead and do the first problem together. You should get out a separate sheet of paper and label it Thermochemistry Worksheet number 3. All right, I'm going to do this right here just for convenience of the video. So this asks how much heat is released. So again, heat we measure in kilojoules, so we'll really be solving for kilojoules. If you have 9.22 grams of glucose, and glucose is this sort of big formula that you might remember from biology. And they give us our balanced equation. Right, now we notice that we just have 1 mole of glucose here, and that's releasing 2,803 kilojoules. So I'll set up my little factor label problem. I want to know how many kilojoules I'm going to get if I start off with 9.22 grams of C6, H12O6. And so the first thing I'm going to need to do is calculate a molar mass for the glucose, which is kind of a big calculation. 6 carbons, that'd be 6 times 12.01, gives me 72.06. 12 hydrogens, that would be 12 times 1.01, would give me 12.12. And 6 oxygens, 6 times 16 would give me 96. Okay, so I add that up and I get 180.18 grams per mole for the molar mass of glucose, right? So I've got grams of glucose on top here. So sorry, this is kind of squished, but I'm going to put the 180.18 grams of glucose on the bottom is equal to 1 mole of the glucose, C6H12O6. So I can cancel out grams on the top and bottom. And now in this equation, the coefficient is just 1, right? So that's why I'm going to put 1 mole of glucose down on the bottom, C6H12O6, and that produces the negative 2803 kilojoules. And cancel out moles. And so now if I go ahead and do this calculation, I'm going to put in 9.22 times negative 2,803 divided by 180.18. And, sorry, this is squished. I get negative 143.4, I'll just round it, kilojoules. And I will circle my final answer. And remember, again, it is important to put the negative sign. Negative sign is telling you heat is released, an exothermic reaction, rather than heat being absorbed, which would be the endothermic reaction. So, when we get to class next, you will go ahead and do the remainder of these problems. And again, you need to make sure that you have finished the first page of this worksheet where you were reading and filling in the blanks.